3, 2, 1. There we go. I think we're live. Chat, please let us know if everything works, sound-wise, audio-wise. That's always the most important thing. And yeah, I'm joined today by two gentlemen that don't need a deep introduction. We have Nick White, who is the co-founder at Celestia. We actually just did an interview a couple of months ago, and we also talked a little bit about shared security, how Celestia is resolving it. Celestia, you also said that on the stream, is basically a Cosmos app chain for block space. You guys are the internet of modular blockchains. So yeah, Nick, welcome to the show. And then we have Sunny, who has been a regular guest on my show now since basically I discovered Cosmos.
Which number episode is this for me? Do you know?
69, I think. But Sunny, co-founder of Osmosis, in my opinion, best DEX, not just in Cosmos, but in crypto. So Sunny, thank you so much for being here as well.
Thank you.
And I think this is a debate, so we have to do it a little bit spicy. And the reason why we're doing this is because after my interview with Nick, there was a thread summary by a community member. Shout out, by the way, for doing that. And in that thread, basically he said that Nick's stance is that mesh security has holes, and there's also some concerns around slashing, right? So the hot take of this debate is that mesh security is oversold and has holes. I guess Sunny will defend that, and Nick will provide some arguments why that should or should not be the case. But yeah, I think we can start off first by a little bit of a general overview of shared security. So maybe we'll start with Nick. Maybe share your views on what shared security actually is and what desired properties you think shared security should provide.
Perfect. Well, pleasure to be here and be back on. And I love the Cryptocito community. I'm also a big fan of Osmosis and also an Osmosis user. Probably like my most used dApp ever. So shout out to the Osmosis team. And yeah, so to start, I think it's really important that we first like take a big picture view of this and say like what is shared security and why is it important, right? And at the end of the day, right, we're all building decentralized applications. And there's a lot of different ways to build decentralized applications, but we're here so that we can build cool things like DeFi or NFTs or DAOs and what have you. And the reason that shared security is a big, like very important piece of infrastructure for building dApps is that I think shared security is what will make it very easy for dApp builders to build secure decentralized applications very easily. So there's kind of two main features of shared security that I think are important. The first one is that you want it to be the case that someone who's building an app, their app inherits security from something other than itself. They don't have to bootstrap security from nothing, because that is it can be a very challenging process to do that. We can talk about like the different approaches, but like classically, you had to build your own crypto network from scratch. You had to, get a bunch of validators or miners. You had to issue a token and get liquidity for that token and value into that token, et cetera. So I think the point, like shared security is meant to lower the barrier of entry to build a secure decentralized application. That's the first thing. The second thing that I think is really important for shared security is secure interoperability. So, when we're building these applications, we don't want them to be isolated like islands, right? Like the power, for example, of Osmosis is not that it's just an exchange, but also that it can talk to all these other blockchains. And so we want a shared security system to be able to make it so that these applications that get launched on it can interoperate securely, because then you get all these emergent use cases. And like that's the end vision of crypto is like that's an internet, right? And Cosmos is kind of obviously deeply believes in that, but like application of websites all were just static and like I guess like isolated on their own, the internet wouldn't have this rich complexity, emergent complexity. So we should strive to get there too, and shared security is a really big part of that. So to wrap up, basically lower the barrier of entry to launch a secure decentralized application, and B, you provide this shared security like to interoperate and communicate between applications.
Sunny, what's your definition and what desired properties do you see in shared security?
Yeah, I think that was a pretty good description. I would say like, yeah, basically, I mean, I agree with most of that. Just this idea that like in blockchains, a lot of the security comes from like economic incentives, and this idea that like, once something happens, breaking the rules of the blockchain or reverting like something that once something has been finalized, reverting that finalization should be a costly, expensive thing. And different mechanisms do that in different ways. Bitcoin, proof of work does that, has its own mechanism for doing that. Proof of stake has its own mechanism for doing that. Other systems have other mechanisms, but and the idea behind shared security is just like, how do we increase that economic cost beyond just, yes, the base case, I think, for most new chains is just to have your own staking token be the one that like, is the security providing, right? It's not exactly, but the security that your chain has is roughly correlated with the market cap of your token, of your protocol's token. And how do we make it so like, can we increase the security cost, especially if you have situations where like the value secured by your network is actually higher than the your protocol's token alone. That could lead to some dangerous situations, and I think we see that on some chains right now. Like, I think probably the one, I think the most obvious one is probably Gravity right now, where I think like the Gravity bridge chain has actually quite a bit of TVL on it, but actually a very low market cap. And so it's like that kind of leads to like a dangerous situation. So it's like, okay, how can we make it so the cost of doing something Byzantine on the Gravity bridge chain is gonna be higher than the actual TVL secured by it? And that's where we approach shared security from, of like, how do we increase that economic costs?
Before we get into the concept of mesh security and also Celestia's approach to it, can you explain and maybe share your thoughts and comments on the current landscape of shared security models? Obviously, I think Polkadot, they have been heavily branded around it with their parachain mechanism. So I don't know who wants to take that first, but maybe share your thoughts on how you see shared security currently on the market.
Yeah, I think there's a couple broad categories of shared security. Keep in mind, shared security is an old idea, right? Like, I would say arguably like Bitcoin merge mining was the original shared security, right?
Mm-hmm.
Like, I'm wearing a Dogecoin shirt from the Dogecoin hackathon, and Dogecoin is actually merge mined with Litecoin. And even Namecoin, the first ever altcoin, was merge mined with Bitcoin. So this idea of like shared security, of like tapping into another chain security, and like to provide security for your own chain, very, very old idea. But I would say like, okay, let's say in proof of stake style landscapes, right? I would say the main like big categories are like, you have your Polkadot model, which is like this relay chain, and you have like this very sort of permissioned parachain system where like you have this like top-down system where Polkadot has a bunch of validators, and then they're like, each of them are assigned to parachains that they're supposed to validate on, right? That's like one model. I think then there's like what the Cosmos Hub. Well, the problem with the Cosmos Hub's security model is like there's different versions of it, and it's kind of unclear like where they're intending to take it, right? Like the V1, which they're calling replicated security, is, I would say, like kind of even more restrictive than the Polkadot model, where it's like basically saying that like, hey, all the validators of the Cosmos Hub have to now be validating this other chain as well. And it's like, I would honestly call that like, it's honestly borderline just a block size increase, more so than like like it's not actually shared security in my opinion, because like the chain that's being deployed is not really fully sovereign in my opinion, as much as it is just an extension of the Cosmos Hub's blockchain. Maybe it has a different governance system and whatnot. Other models that we see right now is the sort of more roll-up centric model that you're seeing happen on like Ethereum, and I think on Celestia as well. And then the last two that I would say are what we call the mesh security model that our team helped develop, and the Terra Alliance module, which are actually surprisingly similar when you actually look into it. I think the Terra Alliance actually has the same basic premise as mesh security. It just architected worse in a it's basically a worse architecture for how to do mesh security. It's like it's adding liquid staking derivatives in a way that it doesn't need to be done. It's like it's like the way someone would design the first pass attempt at designing mesh security. And but I do think the general idea there is the same, where it's like, hey, why do we need one chain to be providing security? Doesn't have to be like. So one thing that's worth noting is in all these other models, right, whether we're talking about rollups or the Polkadot model, the Cosmos model, security is this very one directional thing where it's like this one place, like security starts in one place and it emanates out in this like more hub and spoke style model, right? The idea behind mesh security, both whether it's like the one that we're working on or the Terra design, it's like the idea is, hey, security can be bi-directional. And it can be like multilateral, right? Like you don't need to have one hub and spoke system. You can have two chains combine their market caps to like provide higher security. You can have a coalition of 3 chains or 4 chains. And like, how can you get more and more, you can have the sum of many chains. So I think that's like one big divider between like the mesh designs versus the hub and spoke designs.
Yeah, and I think there's room for another debate in the future with Do Kwon about the Feder and the Alliance stuff. But yeah, thanks for clarifying. And I think that's really the key difference, is that mesh security allows provider chains to be consumer chains at the same time, right? So you have this network of interchain secured blockchains that all secure each other. Nick, in the thread originally that also led to this debate, you posted a tweet where you said, still unclear what actual security guarantees mesh security provides though. So can you maybe explain what you mean by that and what your concerns are?
Yeah, let's get into that. So again, well, it actually might be helpful to actually have a description of like how mesh security works at a high level, just because I think a lot of people maybe haven't gone into the details. And to be fair, my understanding of it was based on the slides that were posted, and this was like late last year, and maybe it's evolved and designed. But as far as I understand, and I'll just do an explanation, I think maybe Sunny can actually like probably clarify because he would know it like much better than I do. But the high level of mesh security, as I understand, is you have, let's say there's the consumer chain, I guess, and the provider chain, and you can have assets like the token of the provider chain, basically, I think deposited into a contract on the provider chain, and then an IBC message basically gets relayed saying, hey, this much stake was deposited into the contract, and so credit me with that much stake weight on the consumer chain. And then that basically they get to like delegate that stake to another, like a validator on the consumer chain. So I don't know, is that like, and then, okay, now if something bad happens, like there's a slashable event or slashable offense that happens on the consumer chain, there has to also be like an IBC message relayed back to the provider chain. And then that smart contract needs to interpret that evidence and slash accordingly. Is that kind of like the right mental model, or is there anything else?
Yeah, I think that's right. The one thing I'd add is you don't actually need an IBC message to relay the evidence back to the provider chain. There's a slasher contract that is like an interface that you can actually implement multiple slasher contracts, right? Like you don't want to rely. You can have it so the slashing message gets sent over IBC, but you don't want to rely on that because you're relying on the chain with Byzantine faults to like relay the IBC packet that will happen. That's like unreliable. So you can just take the evidence directly and submit it as a transaction to the provider chain as well. It doesn't need to be via IBC. So you could, and then the idea is that the slasher contract, there could be many slasher contracts, right? Like there can be one that handles double sign evidence. There's can be one that handles like validity proof evidence. There's like one that you can have different types of evidence systems.
Yeah. Okay. So that kind of checks out with my mental model. And so I guess where my concerns around that model sort of arise is in certain, like it's hard to prove on chain a lot of slashable offenses. And so like, and it kind of comes down to bridging as well. Like it all kind of boils down to the same core problems that people have been struggling with for a long time. But like the core example, and I think probably the most like, I guess, dangerous type of offense that would be very difficult to slash is basically if the validators on the consumer chain, like there was a validator that got delegated from the provider chain onto the consumer chain, and that validator, for example, mines an invalid block. Or like, let's say that like it's actually, in this specific example, imagine a dishonest majority mines an invalid block or adds a new invalid block to the chain. There's no way to prove to the contract on the provider chain that block is invalid. So because basically doing so requires them to have some kind of like either be running a full node and actually fully understand what's happening in the other chain, which is for a lot of reasons, like that's why, like that's a very expensive and just infeasible thing to do. And so without that, like that means that stake can get away with doing something really, really bad and then not face any consequences.
It depends on, okay, so the response will depend on like what stage we're talking about. Like end goal, everything should be using validity proofs, right? Like you should be creating zero knowledge proofs for all state transitions. And like, so even if an invalid state transition is finalized on the consumer chain, then that, you can create a proof, like a proof saying like, hey, like this is an invalid state transition, right? Like if they can't submit a validity proof for it, that's like, they would get slashed for that, right? And so end goal, I don't think mesh security is a replacement for like validity proof style systems, right? Like I think that is the end goal for where all, IBC should, like, IBC is designed with just like client security, because our take was like, this is better than anything that exists, and it's better to have something live and secure. But like end goal, IBC should be doing validity proofs as part of the part of the core protocol. So that's like how that would work. But other, like, let's say we're not at the point yet where like, making validity proof, like, hopefully risk zero kind style stuff like ends up taking off. But like for now, none of these Cosmos chains are using validity proofs or even like fraud proofs or anything like that right now, right? And so how do you deal with that now? It's like, you kind of have to rely on like social slashing until we have like better proof generation systems. But I think that's true for like roll up world as well right now.
Well, yeah, I think we don't really have working models of fraud proofs at scale or validity proofs really. But the thing that's interesting about that though is that like, so I agree with you. So it sounds like we agree that like without some kind of fraud proof or validity proof system, like you just can't slash for a lot of different offenses on another chain. But the thing is then if you want to rely on fraud or validity proofs to work, then you also need a shared data availability layer, because another attack that they could do is they could mine a valid block. This is specifically the validity proof one, but also fraud proof. We could do a different example. They could mine a valid block, but not actually release the data. So they can do a data withholding attack. And then all of a sudden, none of the other full nodes are able to actually know what the state of the chain is. And that's a really bad problem. And without knowing that the data is available, without the provider chain being able to know that the data is available of the consumer chain block, that attack is feasible. So it ends up boiling down, no matter how you cut it, to needing a shared data availability layer for these systems to be secure.
Why does it need a shared data availability layer rather than a data availability layer. Like,
it doesn't need to be shared, but they need a way to verify the data availability of another chain, meaning, and that's something that also cannot happen on chain. You have to actually you have to have your nodes of your chain run a data availability client of another chain.
right.
And the most optimal way of doing that is basically to just end up running the same data availability client as the other chain. Otherwise, like, you just end up adding more and more work for every like connection you have.
So yeah, so okay, a couple of things. One, with the validity proofs, like, yes, you can have it so I guess you don't need the data availability as much in validity proofs as you do with like fraud proofs, like an optimistic rollup style, because fraud proofs, you need it as a bait, like, otherwise no one can challenge it and you can pull off misbehavior. At this validity proofs, like, they literally can't do an invalid state transition because no node or no other like IBC chain will accept that, because they won't be able to generate a validity proof to show that it's a valid state transition. Right. So it actually, like, with validity proofs, your threat model goes down massively. The worst they can do is like hurt the liveness of the chain rather than like break the straight transition functions of the chain. The other take is, like, so when it comes to like shared data availability, I agree that data availability is useful in like some edge cases where it's like, okay, my hot take is, I think that most Cosmos chains have pretty good data availability already. It's called the consensus protocol. You have a few hundred validators. Tendermint kind of gives you high guarantees that at least 2/3 of them had the block data, and as long as one of n is honest, now you have data availability. And I think that's like pretty good guarantees. Now, if you want to improve it slightly, what you could do is, I've been calling this mesh data availability, where, instead of having to have everyone tap into one shared security, like a shared data availability layer, what actually I think will happen is every chain will have its own data availability system. But who are the like clients, who are the nodes, full nodes in this like data availability system, are the validators of all the IBC connected chain. So let's say, like, as an example, what I mean by this, right? So Juno validators are running a data availability like pool here, right? And if Osmosis is running a like IBC client to Juno, what it should be doing is all the Osmosis like nodes should be the light clients to Juno's data availability system. And because part of the thing here is that, like, my worry with like a shared data availability system is it will make it so a lot of people end up holding data that they don't care about. And it's like you have let's say you have two chains that talk very heavily with each other, right? And they're living in like an isolated world, right? Let's say it's crypto.org and Chronos, right? Like, they're just living in their own isolated world. Most chains don't actually need to interact with them and care about their data availability, right? So the idea with like mesh data availability is, it's like, okay, whichever chains that want, if any chain feels that, hey, they have a huge counterparty risk to the data, like a data availability failure of another chain, they should just be able to opt into like making it part of their node to be running data availability like clients for that other chain.
Okay.
Can
There's a lot of things I want to say.
before
go ahead.
I think it would be cool to like slow a little bit down and maybe get back to why data availability, or Celestia's data availability layer, in your opinion, Nick, differentiates to what Sunny just said, consensus kind of as data availability. And I think for a lot of people in the audience that are maybe not technical, as I am, I'm not technical leader. Like, can you maybe explain in simple terms, like, first of what is data availability actually?
Yeah, exactly. I think that's a really important place to start, and that will help kind of frame some of the comments I have on what Sunny said. So what data availability is the answer to the question, has data been published? So in building blockchains, the block data and the transaction data has to be published publicly so that if someone wants to, they can download that data and see what actually happened in that block. And so that's what data availability is like a way for a client, someone running a node, to check that the data has been published. And so where was I? Where to start? So what Sunny said about like, okay, data availability, like we have a good solution for it, which is that we have the consensus protocol. That's the wrong way to think about it, in that the point of data availability, one of the key points is that it allows separate chains to actually trust each other. Well, trust is the wrong word, but not have to trust each other, basically, because it's fine. Like you might be fine as your own chain saying, hey, I trust these validators. They're not going to do it with data. Well, actually, let me also explain what a data withholding attack is. So a data withholding attack is where the validators of a chain, a dishonest majority of them, publish a new block, a block header, where they say, this is the new state of the chain, and we're committing to this. And they do not actually release the actual body of the block, the data, and all the transactions that happen. And the reason that is a dangerous attack is, in one case, they can perform an invalid state transition, meaning they can basically commit to a state that is just completely wrong.
Not if it's validity proofs.
Then they can get away with fraud or like any kind of bad thing. They can just break all the rules of the chain. Or secondly, even if they have a validity proof, they can generate a new state that someone else has to build off of, but not release the transaction data for that person to actually recreate that state. So they can't actually mine a new block. So it is like a liveness attack. So I agree with what Sunny said there. So that's what you're trying to defend against. Now, within a Cosmos model, again, you might be okay saying, well, first of all, I'm not okay. I mean, I would prefer to not have to trust the validator set, not to do a data withholding attack in general. But I agree with that. Like that's something you might be okay with if there's like enough stake and you're like, well, if they do a dishonest majority attack, like we'll just slash them to hell. But the other point of data availability is that there's another chain, and I do not want to have to trust them. And we have no visibility into the data availability. How can we securely, how can we basically be able to interoperate with them without having to make that trust assumption? And having a common data availability layer is how you solve that problem, because all of a sudden the nodes in your network and the nodes in their network are sampling the same data availability layer. And then you're able to check very quickly and easily that the data that they have behind that block has been published. So that solves that problem. And kind of like this mesh, you also mentioned that like if in the Celestia model, this data availability world, people will be holding a lot of data that they don't really care about. And actually data availability layers, so that you're basically describing, that is like the big block problem, which is like, well, why don't we just have bigger and bigger blocks? Even if you have fraud and validity proofs, you end up with this problem of like people having to download more and more data as a block gets bigger, right? And also data that's just not relevant to them. And that is exactly the problem that a data availability layer solves. It makes it so that everyone can share and post their data to this one big block, but only to verify that all that data is available, they just download a tiny, tiny sample of it. And all of a sudden they have a guarantee of data availability, not just their chain, but all the other chains. And they only then, if they can download whatever data they actually care about within that block. And that's why Celestia has namespaces, so that each rollup has its own little portion of the data that it cares about, and you can kind of subscribe to that and download what you care about. So basically what you're describing of like, to me, this mesh data availability thing is just like Celestia, and like that's the problem that Celestia has been invented to solve, if that makes sense.
So I just want to go back for 1 second and ask, like, so how does data availability solve that liveness issue? Like you're saying that like, hey, this having guarantees of data availability makes it. So let's assume we have validity proofs now. The main concern is that a chain stops, like the validators, like you want to make it so validators can't produce more blocks without proving that the data is available. How do they do that with Celestia? Like, because what's stopping them from continuing to make more blocks and without publishing the data to Celestia? How does a full node reject that?
Yeah. So let's say there's a data withholding attack on a ZK rollup, for example, they would publish a new block header. It has a validity proof. Everyone verifies it, and it's like, yep, this state that they committed to is valid, but they don't actually publish any of the transaction data that went into it. Now all the other, and so this one full node, this one sequencer did that. All the other sequencers or anyone else who cares about the state of the chain now can't actually get the latest state of the chain because they have no way of knowing what that is. They know what the commit is, like the Merkle root, for example, but they don't know, they don't actually have the state on their machine, and they're not able to get it. So if they then, let's say that sequencer stops, let's say everyone accepted that block, and then that sequencer just says, oh, I'm actually not going to mine any more data, I'm not going to release that state, then no one else can actually mine on that tip of the chain because they can't actually generate a new block. So the way that data availability solves that is that all the nodes, in addition to checking the validity proof that went with that block header, they also do a data availability check where they first they do data availability sampling on the Celestia block, and then they go and they make sure that the data that was associated with that generating that validity proof is indeed in that block. So that they verify basically like a Merkle proof that data is there.
What happens if that data availability check fails? Like what's stopping?
They don't accept that. They don't accept the block. So then that tip of that chain never gets finalized.
They can choose to not accept the block, but that doesn't stop the validator set from not producing like blocks without data availability. Like
that's like saying that a blockchain's validators can just keep mining invalid blocks, but no full node is actually going to, as soon as, like, they're not going to, those blocks are just like being mined, but no one cares about them because
why is that? So why is that different than any full node just saying, hey, this chain is producing blocks and I'm not able to fetch any of the data, so I'm going to treat it as an invalid chain? How have these worlds like changed now? Like,
so the way that what's changed is that rather than having to download all that data yourself, you sample the data on Celestia, and now you can have I'm running like this ZK rollup client, and there's a bridge between our ZK rollup and the other ZK rollup.
Right.
I'm not accepting they're trying to bridge to me, but it turns out like that block header is not valid because there's no data behind it.
Yeah. Okay. So this is what I was getting.
And also there's also it's basically trust minimized light clients, or what we call light nodes, which is like now I don't have to run a full node to be able to have the security of a full node, and that is useful for end users. It's useful for bridging, etc.
So this is what I was getting at. The data availability is only enforced at the interoperability layer, right? Like,
no, it's enforced natively in the client of all, like, the node software of every rollup.
Yeah, but nothing's stopping that's nothing stopping the validators from continuing to make their chain and not keeping data available. What's going to happen is that no other chain is going to be able to do IBC with them, because what Celestia is basically, what the data availability system is basically saying is that, like, any chain that wants to do IBC with this chain has to first guarantee that its data is available before accepting IBC packets, right? So that's how you do this, like, enforcement of data availability.
But it's not even just for bridging; it's also for the nodes themselves of that rollup.
But my claim is that's true even without a data availability solution. Any node can always say, "Hey, the blocks aren't available. Of course, I'm not going to treat that as a valid." It's like.
Exactly. But the thing is, what that model doesn't scale, right? Because now the more chains that I want to be a part of and run a node for, I need to download more and more data, right? Like, it's linear, basically. Like, okay, there's that much more block data every time I want to be part of another chain. With Celestia, it's sublinear because of the way that data availability sampling works. It drastically reduces the overhead.
You could do sampling with, like, you could just do, like, give me a random leaf in the block, right? Like,
that's not secure. The whole design, like, this is a very technical and in-depth subject that a lot of people have dedicated a lot of time towards solving, and like, you really need a specific design to achieve that in a secure way, which is solutions like Celestia or dank sharding, et cetera, have all been designed to solve that.
It helps with the recovery, right? The reason you want the you want it for recovery purposes, right? You want to be able to say that, like, hey, if 2/3, if the validator completely disappears, there's enough data that's available that, like, we could recover the chain, right?
You need the erasure coding. Both, it's the reason you do the erasure coding is so that it's harder to hide data, because now, let's say I have this, just the actual block data. Now, if I wanted to hide a little piece of it, right, I have to literally download the whole thing before I find that. If I just randomly sample the block data, it's very unlikely that I'm going to land on that one piece that was hidden. Right. Now, if I extend it, all of a sudden, in order to hide even a small piece, I have to hide a huge portion of the block. So now every time I sample, I'm more likely to touch on that one thing. And then the block reconstruction is something that you do so that, like, if you need the actual data, like, you can recover it from those external. It makes that whole sampling thing actually secure.
Okay, so then go back to, like, the mesh architecture, right? Like, why do I, as a chain, why would a chain not just implement its own, like, erasure encoding, like, and, like, data availability scheme, like, within its own protocol, rather than, like, submitting this data to, like, a third-party chain as part of its, like, consensus validity? Because
in the case of bridging, now if I'm a node, let's say there's two chains, they each have their own data availability scheme and network. Now they want to talk to each other. It doesn't, they now have to actually run a data sampling like client of that other chain in addition to their whatever normal, like, client, like IBC client or whatever. So now, if every single time you want to make a bridge with another rollup, you have to run another client. And so, like, it doesn't end up scaling either. And it makes more sense for them all to share one common data availability layer and just run one client that gives them access to everything. If that
why does it not scale as well? Like, why does it not scale as, I guess, like, why does it not scale as well as, like, otherwise everyone still has to run a data availability, like, client for Celestia? And why is it not scaled to just, like, run data availability clients for every counterparty chain?
Because then so now the node, literally the node software for your chain has to run for n bridges, you have to run n data availability clients.
Yes.
So that does not scale. And you're going to have to sample n times the amount of data. Versus if you do it with a shared data availability layer, you run one client and you only have to do data availability sampling once.
But that one client has to do a lot more data sampling.
No,
right?
So the whole point of data availability sampling is that it's very, very minimal sampling, and it scales sublinearly with the amount of data.
Yeah, it scales, like, roughly square root, right?
Yeah.
So I guess the question is, like, how much of an overhead is it going to be for, like, the linear case? I know, like, David C is, like, actually doing some research on this right now, because I pitched this idea of mesh data available to him. He got, like, really excited about it, and so they are doing some research right now on, like, how much the overhead is. I definitely agree there is going to be an overhead to, like, or higher side, like, higher overhead to mesh data availability. I just think it seems to be where it's, like, I don't know how it naturally will evolve, because it's like, instead of having to rely on a third chain for two chains to talk to each other, it's like, well, kind of I guess one of the ideas behind the IBC architecture has always been, like, make as few third-party, like, assumptions if chain A and chain B want to talk to each other, like, minimize as much third-party assumptions as you can, right? Like, don't have to, the bridge should have equivalent security to the two chains themselves. And that's why I think the mesh data availability is going to become popular, because it's going to be like, hey, I'm already trusting this other counterparty chain for, a bunch of, like, my trust assumption here is equivalent to the economic security of this counterparty chain. I might as well trust them for the like have my data availability follow that same like security assumption.
Mm-hmm. Yeah, I mean, the other thing is just frankly, then every time it's not just like the scalability of like how much you have to sample, but imagine every time you want to launch a new bridge, you literally have to update your node software with another client, and there also might just be a limit to the amount of like how many peer-to-peer networks can your node connect to? You know what I mean? But
that'll be automated. Like today, like when you have to run a new IBC client, you don't have to upgrade node software to run new IBC clients, and I imagine it will end up being similar for how like data availability sampling will work as well. I hope.
Like, yeah. I think we focus also like a lot on this security part, right? There's two things about shared security. One is the ease of making it really low overhead to deploy, and then the other one was this secure interoperability. We've done a lot on the secure interoperability. I kind of want to return to the like making it really easy to bootstrap security, and like from my perspective, like you want to make it as easy as possible and low overhead. And at least from what I understand with mesh security, it might solve to some degree the economic part. Like, okay, well, we don't have to, it doesn't matter if our token is as valuable because they can basically delegate their valuable token to stake on us. Although, I mean, we can touch on this, but there's still going to need to be value in their token, and that like that's the reward that they're issuing, right? So if that reward is not valuable, who's actually going to want to you know, do mesh security staking? But the other thing for me is like you're still not solving the core problem, which is that if in a mesh security model, every new chain still has to have a new validator set, run its own consensus network, and all of that, which is a huge overhead. And one of the main benefits of using Celestia as a shared consensus and data availability layer is that you don't have to bootstrap a new consensus network every time you want to deploy a new chain. You just plug into a pre-existing consensus network. So it like really, I mean, our goal is to make it as easy to deploy a new blockchain as it is to deploy a smart contract on Ethereum. And I think we can get there. And like, I just don't think mesh security can ever get there in at least the way that I understand it, because you're always still going to have to bootstrap and maintain a new validator set, a new network.
So I think, I mean, a couple of things. One, I think all rollups should be bootstrapping new validator sets anyways. I don't think like single node operator rollups are okay. But and then the other is that like you don't have to have your own token for mesh security, right? The mesh security architecture is like, you know, you can use like the interchain security kind of replicated security architecture that like Cosmos Hub is doing is almost like a subset of the mesh security design, right? Like you can have a chain that's only getting security from other chains, and you don't actually need to have your own token at all to like bootstrap this, to like to start the system. And that would be the same as how like ICS works.
And then you just pay. How do you compensate the other chain?
Fees.
So another thing I want to touch on on the rollup sequencer part, I disagree in that what I think is important is that rollup, whoever's building their chain can choose. Like there actually might be rollups where having a centralized sequencer is fine. But the other thing that you said, you assumed that bootstrapping a decentralized sequencer network is the same as creating a new validator set. Is actually quite different. And there's some really exciting proposals, one by one of our engineers, Evan, about how you can actually have a sort of not permissionless, but a shared sequencer network. So rather than having to bootstrap a new set of sequencers every time you want to deploy a rollup, you tap into a pre-existing sequencer set. And so it can actually work out of the box in a decentralized way. And so again, like you can actually get to a stage where you don't have to bootstrap a new validator set.
Isn't that the same as how ICS and mesh security work as well? Where like, look, here's a bunch of existing validators. You can just tap into them to become the validators of your chain as well.
There's similarities, but it's quite different in that they're not validators, they're just sequencers. So all they do is basically run the mempool and they order transactions and post them as a block. But they don't even need to actually understand the execution of your chain.
So who's creating like stake roots?
So then you can have a separate set of nodes that ingest that data that gets posted on chain and generate state roots and the associated proofs.
Why?
So it's like,
split
it's kind of
them?
like, it's kind of, again, so like Celestia is based on this idea of decoupling consensus and execution, but
Yeah.
then at the roll-up layer, at least the way that it's built now, you still couple sort of like ordering or like sequencing and execution. And then what this idea is basically is like, oh, actually we can again decouple sequencing and execution. And I mean, it's still yet to be built, but like it's to me a really, really exciting solution for like how you can deploy a roll-up that has great liveness and censorship resistance without having to bootstrap a decentralized validator set.
Yeah, like,
But yeah,
I mean, yeah. So you would still need to, I guess, like part of it is like, you know, a lot of, you do lose out a lot by like not having your sequencer be application aware, right? I think this is like one of the biggest I would argue maybe one of the biggest selling points of like app chains is that, hey, I can have my block production system be application aware. And like, I think that you lose out on one of the most compelling properties of app chains if you like separate your application logic from your block production logic.
Mm.
Can I just throw in an example here? Because Sunny, you mentioned earlier the gravity bridge that has a relatively high TVL to their kind of like economic security or economic value, market cap of the chain. So let's assume mesh securities in production, Celestia is live, and also interchain security on the Cosmos Hub. If I was Gravity Bridge or even a new chain that I want to launch, and I want to explore shared security models, like what would be the case to say I would prioritize mesh security over Celestia over interchain security? Like what would be potential trade-offs or benefits? Maybe Sunny, you want to start?
Yeah, I think mesh security, like, it's a framework that can be used in many ways, right? Like you can use it as ICS. You could say like you could use it in a way that like you don't have your own token or anything and you just want to bootstrap it from an existing chain, right? You might be like, hey, I have, you know, you're a contract on Juno and you decide like, hey, it's time for me to spin off onto my own chain. You can just like, but you don't have a token or anything, right? You can just be like, hey, Juno validators, who wants to like, you know, help secure this new chain, right? And you can do that with mesh security. For like the gravity style case, that would be more of a situation where it's like, hey, they already do have their own token and their own staking system, but it's like, wait, we need more security on this chain. Why don't we like go to the biggest users of our chain who would also be impacted by this and like have them also secure us? So like, let's say for gravity, right? Like Canto is probably the biggest user of like dependency on gravity right now, right? And so it's like, so the example I usually give is like Osmosis and Axelar, where 6, I think, out of the top 10 assets on Osmosis are bridged via Axelar. Meanwhile, like Osmosis makes up like over 70% of Axelar TVL. Like these two chains have such high dependencies on each other. It would suck for both of us if either of us got attacked, right? And so it is just like an obvious thing where like, hey, we would want Osmosis market cap to be helping secure the Axelar bridge, and the Axelar would want their market cap to help secure Osmosis because we're their biggest customer, right? And so I think the same thing, that's like the version, that's the use case of mesh security that like I'm mostly thinking about, but that's mostly because that's what Osmosis needs, right? Like we don't want Axelar to get attacked. We don't want Mars to get attacked. We don't want Stargaze to get attacked, Juno to get attacked, because these are our biggest economic partners, right? And so that's kind of the use case that we care the most about.
Can you explain from a user perspective, let's say Axelar and Osmosis would mesh secure each other, like how would that work? What's the economic incentive model? Maybe you can explain that.
Yeah, so what will end up happening is basically Axelar chain will say, hey, so okay, how does mesh security work? Is you have Osmo staked to a validator on Osmosis, but now Axelar comes along and say, hey, you can actually we accept Osmo cross staking, and you'll get voting power on Axelar, and that means you'll also get some Axel rewards. It could be less than you would get if you actually converted your Osmo to Axel and stake that, but you'll still get some rewards. And it's like, it's a no-brainer basically, right? Because you're basically like getting more rewards with just all you're doing is you're opting into additional slashing risk for, you know, if axelar does anything malicious to the validator that you delegate to an axelar. So what'll end up happening is that like the economic incentives will drive it so that almost all Osmo stakers are also co-staking on axelar. And then the same thing's going to happen in the other direction. If Osmosis allows Axel co-staking, like the economic incentives will drive it so most Axel stakers are also co-staking in Osmosis, and you end up in a nice similar equilibrium where you actually end up emitting the same amount in rewards, right? You don't increase the amount of like staking rewards that have to go out, but you just ended up in a world now where like you have the market. What's securing Axelar is the sum of the market cap of Axel and Osmo rather than, and same. So the sum of the market caps are securing both chains rather than just one market cap per chain.
And mesh security is always bidirectional, or is that optional?
It's completely optional, right? Like it can be one directional, it can be bidirectional. Yeah.
So technically,
I'm curious, is that restaking too, by the way? Like, are you taking...
Yeah,
like,
it's very
basically
similar.
like the staking derivative and restaking it.
You don't use the staking derivative, so that's what like Terra's Alliance does, which I think is the wrong architecture. The idea is right. We call it cross staking. We didn't call it restaking just because we have this thing already in Cosmos called redelegation, and we didn't want it to be confusing with that.
It's a good meme though, restaking.
Yeah, it's basically like the same thing, right? It's like, yeah, you're saying, hey, I have this Osmo staked, and then you're just opting into additional slashing conditions. So yeah, it is very similar to like the restaking architecture in Eigenlayer, or this is literally what, like, you know, we've been working on this the Cosmos Hub ICS v3 was the same idea as well until it sort of got abandoned. So yeah, very similar to restaking.
Do you see, okay, because we're running out of time soon, there's a lot of activity in the chat. Let me ask you, Nick, first, where do you see the end game for shared security?
Well, I think that the most like scalable and like the version of shared security that is the most scalable, has the lowest overhead, and gives you the most secure interoperability, which is kind of like the properties that really matter. Is using data availability and rollups. So basically the modular blockchain stack. That said, I'm also not a maximalist, and I think that what's important is that people choose whatever stack works the best. And so I think it's important to have different models like mesh security or ICS or, you know, all these other models that we talked about earlier on. But I do think that long term, something like the modular blockchain stack is the right way to go because it has all the desired properties that you want. So that's what I believe is the end game for shared security.
So you think it's going to be built on a modular stack, but there's not just one winner that takes it all, right?
Yeah, I think that there's going to be probably like many data availability layers. There already are, you know, emerging multiple. But I was also trying to say that like there's also going to be monolithic chains or like different models of security that are not only strictly modular. But I do think that long term, like a majority of shared security will be derived using a modular model. And I think the majority of new blockchains will be deployed as rollups on top of data availability layers, just because there's just so many advantages that you know, as a builder, I think people will make that choice voluntarily.
Sunny, where do you see the end game of shared security? And do you think there's going to be one winner or multiple dominant players?
So yeah, I mean, admittedly, I'm not a biggest believer in like the modular thesis. I like Osmosis has always been one very like focused on vertical integration, right? Like we like, you know, we can build our role model is Apple, where like, you know, build the OS, build the apps, build the hardware, build the chips, right? Like you can build the best features and the best UX if you control the entire stack from like top to bottom. And like, I think over outsourcing out parts of the stack is like or I think what maybe works is you start by outsourcing out parts of the stack, right? Like Apple, like outsourced a lot of its like manufacturing, but like over time, you know, I think they're starting to work on, you know, their A1 chips and stuff. They've in-housed that. I think like there's more and more stuff that as you in-house it, you actually just get like better control, and you can build more performant, more better architected things when everything's so more vertically integrated, right? Like I think you're going to end up getting a lot of latency when you start to like, you know, okay, you first have to go to like a sequencer, then you have to wait for data availability, then you have to now wait for the execution side to happen. It's like, you know, versus if you just like have this all in one integrated system, I think it'll just be a better experience. Now that's not to say I think things will get, I think some things do get outsourced, right? Like as an example, bridges, right? Like Osmosis made the choice that like, hey, we don't want to build like non-IBC bridges, right? We're like, hey, we don't want to build our own bridge, right? That seemed like too much work for us and way too high importance and high security, and like that we, you know, we want to outsource this to a team that's like focused on just that and providing the best bridging experience. But we want to make sure it's someone that we're like deeply integrated with, right? Like if we were just like with, you know, I personally, I think that's one of the reasons why we really wanted to work with Axelar instead of, say, I don't know, any of the other bridging options, Wormhole or something, right? Just because I thought that like, hey, Axelar was like young and scrappy, and that they were able, you know, we were able to like build a very integrated product together, right? They were like a close partner rather than just this like distant, like uncaring, like you know, provider, bridge provider to us, right? And so I guess it comes, I don't know where like data availability will fall into that. To me, it's like maybe people want to just outsource it versus I guess my belief is that like if it is something that's like very simple enough, that's just like a module that people just tack on to their, you know, you just import a module to the Cosmos SDK and now your chain is acting like a data availability system for itself. I think that like might be what ends up happening. I think it depends on how easy it is, right? Like right now, IBC, every chain, it's like, you know, you just import the IBC module and now you have like IBC. You don't need to like go to an IBC provider chain to like provide that for you. So we'll see how data availability sort of ends up playing on that.
There's also Babylon, which is bringing sort of Bitcoin security, because you mentioned earlier also the concept of merge mining, and I think Babylon originally started off as trying to merge mine Bitcoin with Cosmos chains. But I think it's going to be interesting to see how that works also with their checkpointing mechanism. Maybe that's a completely different episode, I guess, for the future. But yeah, Nick, do you have any final comment? I think you wanted to say something, right?
Yeah, well, I just wanted to say that I feel like Sunny and I are actually not that far off. Like a lot of the things that you're describing are actually basically what Celestia already is. So like when you're talking about this like module, like Celestia is that easy to integrate with. It's not a Cosmos SDK module for your own chain, but it's literally add this light client, this data availability client to your node software, and all of a sudden you have data availability and make your block producers post data, you're done. Like that's like Celestia was designed to be modular, right? And to be that easy. So like I think that we're actually not that far off from like being in agreement and and I think that the long term, like the real vision is, again, make it as easy to deploy a blockchain as it is to deploy a smart contract. And that's like what Cosmos has always been about. And I think that the modular stack is a very, very important piece of infrastructure to actually get us there. And we want to see like thousands, if not millions of rollups eventually. And like, I don't see how someone's going to be able to bootstrap a validator set 1,000 times or 1,000,000 times. And then just the overhead of running millions of consensus networks in parallel just is like so mind-blowingly like inefficient. Like why not just all tap into one shared data availability layer? We all share one consensus network and we share the costs and we get all these benefits. That's my vision. And I think we'll see how things play out.
One cool thing was when we were debating about this on Twitter, one thing that you pointed out helped us like come up with this like new idea for Cosmos, so we're writing a blog post on this, so it will be out pretty soon, but it's called interchange sanctions.
Oh.
And it came from this question that you had about like what happens if the provider chain is just censoring the evidence from being submitted because they don't want to get slashed, right?
Yeah, exactly.
And so our solution to this was we realized, hey, well, what we could do is go ahead and like let's say Osmosis was censoring some evidence, or what we realized you could use this for actually any transaction, not just evidence. But let's say Osmosis was censoring any transaction. Well, what you could do is you could submit your. I think this actually becomes harder to do once we have threshold decryption, anyways. But let's say there's another way of censoring. What you could do is you could submit your transaction to the IBC channel on Juno, and you call it a priority transaction, where what that means is it says this transaction says I need to be processed before any more packets on this channel are processed. It's like kind of like an ordered. It becomes a temporarily ordered channel, and what this does is it basically means that the communication between Juno to Osmosis is blocked until that transaction gets relayed to Osmosis and processed. And you can imagine this is effectively Juno sanction. It's like how countries in the world, when like some country does something they don't like, that you put economic sanctions on them. You cut off trade with them. It's very similar to what's happening here. Like Juno is cutting off economic activity with Osmosis until Osmosis stops censoring. And you can take your transaction and you can put it on every counterparty chain or major counterparty chain to Osmosis. And so that way it's like, all economic activity with Osmosis automatically stops until that transaction gets processed, and then economic activity continues. And it's like a really cool way of like, I don't know. It's a nice like way of like preventing censorship that has this like very obvious, like, I mean, everyone knows how much I love these like real world geopolitical
analogies. Love the analogies. Yeah, I love the analogies with like countries. It's really, really similar. I love that. Cool.
Interchange sanctions.
I feel like this was just round one. I think we should do this again sometime. Comment of the stream goes to Galatasaray CA. I feel we need Nick and Sunny to work in the other person's job for a month. These guys are super smart and will learn a lot. Do you think you should do that? That's
good advice. Yeah, it's always, it's important to like understand, walk in someone else's shoes, you know what I mean? And I do think that like the Osmosis team has probably the most expertise in like building like app chains, like the full stack thing, and have thought this through. And like, that's not the approach that the world that I come from, So I think there's a lot of validity in that.
Yeah, I think that this was super productive. Very engaged live chat, and we should do this again. There's a lot of things I think we didn't touch upon, also different concepts of shared security. But thank you so much, also everybody in the chat. Thanks, Sunny. Thanks, Nick. Always glad to have you on. And yeah,
I guess like one question. Sorry, really quick. What was your thoughts on mesh security? I feel we ended up actually talking a lot about data availability, right? Like, did you have any issues with mesh security specifically?
Me?
Yeah.
Just the slashing thing. Like I just don't think like that's not secure, basically. And also like and it's not just about like what can you prove on chain. It's also like what you touched on of like that if a provider chain is providing security, does it have any incentive to slash itself? You know what I mean? Like maybe that's also corrupted. And so and
Okay.
and like
But I think we talked about this, in the in the first quarter. But yeah, thank you so much. We'll definitely do this again and then go deeper on all these things. So yeah. I got to run now, and we'll keep in touch. Thank you, everybody.
Thank you, Cito. Thanks, everyone.
Cheers.
See you,
Thanks.
Sunny.
Bye.